Good morning, students. Today's topic of discussion is refraction of light. So I hope everyone have finished doing their numerical problems, right, on magnification and all that, which we have discussed earlier. I already showed you how to calculate, right? So I hope so you already did those problems, and if you have any difficulties, then you ask me, okay? But I will discuss only on those days which we have. For example, some of you are asking me about chemistry on a day which I do not have chemistry, right? So if I have I told you that I'll be having physics on Monday and Tuesdays, right? So if you ask me, you can ask the question based on physics or chemistry on any day, but the answers I'll be giving you on the days which I'll be having those subjects, okay? So that it won't be confusing for you, right? So here, before going to today's topic, right, I would first want to discuss with you the first point, that is, what is a medium? Okay, so many of you, we have discussed reflection of light. We already know what a medium is, right? So that medium is what is a medium? It is any material through which light passes, okay? So any material through which light passes. For example, during the reflection of light, light passed through where? Through a concave and convex mirror. It was reflecting actually, right? But in refraction, they need this medium because it is any material through which light passes, okay? You understand? So a medium is any material, be it air, glass or water, all right, through which light passes, okay? That is called a medium, all right? So let us discuss the here they even talked about transparent medium, okay? So a medium which allows light to pass through it almost completely is known as a transparent medium, okay, where light can pass completely, right? There are some mediums, for example water and glass, where the the light cannot pass completely, right? Like for example in a room, okay, light cannot pass completely, right? However, outside light can pass completely, okay? So the medium through which light can pass completely, it is known as a transparent medium, all right? So in medium, what is important? Transparent medium. So you study the definition of medium and transparent medium from here, okay? Okay, moving on to the next point, we will discuss the activity. Okay, so we will discuss activity 6, okay? So before discussing the activity, I would like you to see the figure, okay? Suppose we take a pencil, okay? Suppose we take a beaker, a glass beaker, which is transparent, all right? We fill it with water, okay? However, when we take a pencil, when we look at the pencil, all right, without immersing, we just look at it like, suppose I'm holding this pen, I look at this pen, okay? It is longer and you know, I can see the image properly. But what happens when I dip this pen inside the water? What happens? This pen will now appear to be shorter. Okay, if I dip this pen inside the water and I observe from the water medium, right, this pen will appear to be shorter in size. Why do you think that is so? Okay, that is because, okay, when I'm holding my pen here, right, this medium is air. I can see the pen properly, right? However, when I dip this pen inside the water, what happened? I am observing the light through a different medium. And what is that medium? I am observing the light here. I am observing the light through the air medium, right? Nothing is there. But when I dip it inside the water, I will observe the the pen through which medium? Through the water medium, all right? So air is it's a rarer medium, means it is not that dense, okay? However, water is a more denser medium than air, all right? So that is why the pencil appears shorter, and also it appears to bend, okay? It appears to bend. Here I'll just hold like this, you'll see. But when I dip inside the water, this pencil, which was straight, right, it will appear to bend and it will appear shorter. And this is because of one phenomenon, that is the, what is it? Refraction of light. Okay, because of refraction of light, that's why this is happening. That's why you can see that the pencil is bending, and that's why you can see that the pencil is shorter. Okay, this is because of refraction of light. So what is refraction of light? Okay, so refraction of light is a phenomenon of light traveling from one optical medium to another optical medium. You understand? So like for example in activity 6, light travel from air to water, right? It traveled from one optical medium to another. You understand? So that is refraction. Okay, refraction is the bending of light rays when it travels from one medium to the other. Okay, see, the conclusion of this activity is light bends from its path while traveling from air to water and vice versa. All right, it is because this light travels from air to water, therefore it bends. The light ray bends. Okay, and vice versa. What do you mean by vice versa? That is when the ray of light passes from water to air, also it will change. Okay, see, air to water also it will change, and water to air also the light will bend and it will change. Alright, so from here, see, from that activity we came to a conclusion that light bend from its path while traveling from air to water. Air here is what I told you, it is a rarer medium, and water is a denser medium. Alright, you understand this? Water is denser than air, right? So air is a rarer medium and water is a denser medium. Alright, next we will see, this is very important. Alright, what is refraction? I already told you what is refraction. Refraction is the phenomenon of bending of light ray when it travels from one medium to the other. That's why, see, because the light ray was traveling from one medium to the other, that is from air to water, right? In that small activity which we discussed, that's why the pencil appeared to be bending and appeared to be shorter in size, right? Because the light was traveling from air to water, that is from one medium to other, therefore there is a bending of light rays. All right, so you study this in this definition, very important. All right, what is refraction? Okay, so as homework I want you to go through and understand activity 7 on your own. Okay, so activity 7 is very easy. Okay, they just took a coin. All right, they put it in a what had they sent here? Okay, in a china mug. All right, they just kept a coin there. When you see, okay, see in figure 1.44, number A, the coin is kept just like that, and when you observe the coin in the air, right, there is nothing in the cup except air, right? You can see that the coin is at the bottom of the cup, right? However, what will happen if you fill water inside that mug? Okay, if you fill water inside that mug, what will happen? The coin will remain there only, but since there is a bending of light rays, it will appear as though the coin is floating. Okay, the coin is shifted, the coin has shifted its position. Okay, so it will appear as if the coin has shifted its position. Why? Because you added water. Okay, and water here acts as a denser medium. Okay, see in figure A, in figure 1.44a, the coin, it was only air, right? It was a rarer medium. So you can see that the coin is at the bottom, right? At its original place. However, the light was traveling from just air, right? Now when water is added, the light is traveling through the water and then down. So that's why it moves to a denser medium. Therefore, the coin will shift its position, all right? The coin will be shifting its position. You understand? So that is refraction of light. Okay, that is an example of refraction of light. Okay, so I hope so you understood that. So just go through this one. Okay, I didn't discuss it nicely, so just go through. I just went in brief with that activity number 7. So you just go through and understand about it. Okay, and the important terms you can underline. Okay. So the next topic is causes of refraction of light. But before going to the causes of, okay, fine, we'll just discuss. Okay, so causes of refraction of light. Okay, forget this for now. So the causes of refraction of light. What causes the refraction of light? Why do you think there is refraction of light? Why do you think these light bends? This light ray bends when it travels from one optical medium to another. When you say one optical medium, that is from rarer to denser or denser to rarer. All right. See, the cause of refraction is the change in speed of light from one medium to another. Okay, this is the main cause. The main cause of refraction is the change in speed of light. Okay, you know that light travels at a certain speed in air, right? Light travels at a certain speed in water, and light travels at a certain speed in glass, right? Those are the three mediums which we will be talking, okay? Air, water, glass. All right. So I'll take a simple example here, okay? Let us take a simple, see, you understood this, right? The cause of refraction, why does refraction occur? It's because there is a change in the, it is because there is a change in the speed of light from one medium to another. This is very important, from one medium to another, okay? See, for example, I'll take this example, okay? Let's discuss the example. Example of this is, this is an interface, okay? Just a line I'm drawing like that. Suppose your car, right? This is a normal road. This is a road which has, you know any normal road, okay? Which cars are driven, like the road is very plain and it is very, there are no holes, there are no potholes, there are nothing. The road is very clean and very well, well made, okay? So obviously the car, okay, walking from the car running in this road, right, going through this road will have a full speed, right? You can drive your car with full speed in this type of road, okay, which is very plain, right? You can drive very fast, right? So the speed will be full, right? However, suppose this is one place A, okay? There's one place A, okay? We'll name this place maybe Limekra. Alright, so this is Limekra, and you know that the roads in Limekra are they're good, right? So the car will move fast, like without the traffic, of course, okay? So the cars will move very fast from here, right? However, there will be a junction point, and this will be place B. There will be a junction point where this car will reach a certain place, okay? This place is very muddy. Alright, this place is very muddy, and roads are not properly built in this place, okay? So what will happen? Okay, what will happen when a car moves to a muddy muddy surfaced road with no nice, the roads are not well built and everything? The car, what will happen to the speed of the car? Do you think it will walk the same speed, it will cover the same speed as it covered in place A? No, right? Because place B now is muddy, okay? So the speed will decrease, right? The speed will decrease, okay? And since it is walking in this direction, okay, it was supposed to walk in the same direction, right? However, when it reached this place, a muddy place, the direction changes to here, okay? Direction changes to here, okay? So this tells us that this is a rarer medium. This tells us that this is a rarer medium, example, air, okay? And this is a denser road, all right? For example, glass, all right? So since this car is moving here with full speed, but on reaching the denser road, what happened? Its speed decreases and it moves, it bends towards the normal. So what is a normal? This I already told you, right? Suppose there is a ray of light coming here. So the normal will be, which is perpendicular, right? So this is the normal, right? So it will bend, this one will bend towards the normal, okay? So I hope so you understood the simple example of the car, right? In a normal road, a good road, the speed will be fast. However, in the muddy road or denser road, the speed will be less, all right? So we will discuss this way. So now we will move on to the cause of refraction is the change in speed of light from one medium to another. Okay, so now if light goes from rarer medium to denser medium, these are very important rules, okay? You have to remember these rules, okay? I'll discuss the first one first. This you have to remember by heart. If the ray of light goes from a rarer medium to a denser medium, then the speed of light decreases in denser medium, okay? As a result, the ray bends towards the normal. See, suppose I have the interface, okay? We all have interfaces, right? Even during reflection of light, okay? Right? There's an interface. Suppose this part here, right? The first part here is air, right? And the second part here is glass, okay? So this is a ray of light. Suppose a ray of light is coming, a ray of light is coming. Okay, since it is in the air, it is coming like this. But according to the rule, air is a rarer medium. Air is a rarer medium and glass is a denser medium. You know that, right? Okay. Since air is a rarer medium, what does it says? If light goes from rarer medium to denser medium, the speed of light decreases. Okay, the speed of light will decrease. Alright, in denser medium. Okay, so here I told you, if a light is incident, what will you draw? This is a normal, right? Then what happened? As a result, what happened? The ray bends towards the normal. Okay, see, this is the normal. Towards the normal means closer to the normal. From here, it won't go normally like this. Okay, it was supposed to go normally. If it is air, this ray of light will go normally like this, right? But see, it will go normally like this if it is air. But since it is glass and it is a denser medium, therefore the speed of light will decrease and also the ray of light will bend towards the normal. It will bend towards the normal. Do you see? It is coming towards the normal. Understand? Okay, so this, I hope so you understand the first one. If the light goes from rarer medium to denser medium, then speed of light decreases in denser medium. Okay, that is, see, here the speed of light will be more. This is the incident ray, this is the reflected ray. So incident ray will be more than the reflected ray. Okay, so the speed of light will be more in air than in glass. Alright, okay, and then it decreases as a result the ray of light bends towards the normal. Remember that if it goes from rarer medium to denser medium, it will bend towards the normal. Okay, then number 2, if the light goes from denser medium to rarer medium, then speed of light increases in rarer medium. As a result, the ray bends away from the normal. Okay, suppose we have an interface again. Okay, however, in the second part, this here we have glass, which is a, tell me, it is a denser medium, right? Glass is a denser medium, and here we have air, which is a rarer medium. Alright, so what happens? A ray of light will come, right? A ray of light will come, and then you have what? The normal, right? Here it is incident. Alright, incident ray. Alright, incident ray. So here the ray of light comes, but since this is a glass and a denser medium, and this is a rarer medium, so here what are they saying? If the light goes from denser to rarer medium, the speed of light increases in rarer medium. Obviously, it will increase more in air. The speed of light will be more in air. As a result, the ray bends away from the normal. Do you see this normal? Here it bends closer to the normal. But here, since it is from denser to rarer, the ray of light will go away from the medium. Away from the normal, sorry. Away from the normal. Do you see this? This is the normal. It is going away from the normal. Alright, so in this case, this is the reflection, right? In this case, angle of reflection is more than the angle of incidence, and the speed also is more in air, in rarer medium than in denser medium or glass. Alright, so let me discuss to you the molecules more about this. Okay, I already told you that there are 3 mediums that are going to be discussed in this refraction of light. That is air, which is rarer medium, water, which is denser, and this is more denser. Alright, so air here is a rarer medium. See, rarer medium as compared to water, right? However, if you take water and glass, water will be a more rarer medium than glass, because this is denser, but this is more denser. You understand? And same way, air and glass, air will be rarer and glass will be denser. Why is this so? Why is there a rarer or a denser medium? Right, this is because of the molecules that makes these 3 mediums. Okay, we already discussed in class 9. Okay, in class 9 you should already know that we've already discussed about the molecules of air, water and gases, right? Here we'll discuss about the molecules of air, water and glass. Okay, in the air, what happened? The molecules are widely spread because air is a gas, it is a gas, right? So the molecules will be, suppose this is air, right? So the molecules will be here, 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 here. They are not tightly packed, right? However, in water, okay, it is like this. Okay, they come closer in water. However, in glass, what happened? The molecules are very tightly packed. All right, so that is why the ray of light bends. That is why they are considered as a rarer, less rarer, and more denser medium. All right, so we'll discuss about air, water, and glass only in this chapter. Okay, these are the mediums that we will be discussing. All right, so I hope so you understood the molecule distribution in air, water, and glass. Okay, these are like solid, liquid, and gas. Okay, how the molecules are there in solid, liquid, and gas. Because of this molecule distribution and because of this molecule orientation, therefore this is why the speed of light is more or less. So the speed of light is more in air than in water than in glass. All right, okay, let me just write that somewhere. Speed of light. So the speed of light in air, it is more in water than glass. So if I ask you, where is the speed of light more, air, water, or glass, you will tell me air. And where is speed of light very less? It is in glass. Very less, very high. Okay. All right. So the next topic we will go is this: the terms associated with refraction of light. This is just like reflection of light, right? We already discussed. Okay. We already discussed about reflection of light also with these terms. Today we will discuss about the terms associated with refraction of light. Okay, so okay, this one. Okay, so the first one is incident ray. Okay, incident ray. Before discussing this terms associated with refraction of light, okay, we will see this one here in your chapter. This is written refraction of light through a glass slab. Through a glass slab. Okay, I want to discuss with you this figure first. All right, let me just cover this. Okay, so let me discuss with you first this glass slab, refraction through a glass slab. So this here is a glass slab. All right, this whole rectangle thing is a glass slab. Okay, means it is a rectangle thing which is made up of glass. Okay, here what happens in this glass slab, if you keep there, right, light will come and incident on this glass slab. Okay, forget about this. Okay, forget about this first. All right, forget about this first. Okay, just remember that this is a glass slab and this one. All right, see, do you see this part here where the incident ray comes to the glass slab? This part here is air, right? This is glass. Okay, so the incident ray will come and land here on the glass. Okay, whenever an incident ray comes and incident on the glass slab or anything, what happens? You have to draw the normal. So there I am drawing a normal, right? After incidents, okay, what happens to the ray of light? It gets reflected, right? So here, since it is from air to glass, right, and there is a normal, okay, so since it is from air to glass, right, the incident ray comes, right, then you draw the normal. Air here is a rarer medium and glass here is a denser medium, right? As per the rules, right, as per the rules we just discussed earlier, what happens when the ray of light comes from a rarer medium to a denser medium? What happens to the reflected ray? It bends towards the normal. So because of that, there is a normal here. This reflected ray will come closer to the normal. You understand? So angle, see, oh gosh. So here the first term is the incident ray. So what is the incident ray? This we already discussed in reflection of light also, very simple. A ray of light traveling towards another optical medium is called incident ray. Okay, see, this ray of light coming towards another optical medium, that is glass, because this medium is air. So a ray of light coming towards another optical medium is known as incident ray. So the first one is incident ray. So here I named it as PO. So this PO here is the incident ray. All right. Now the point of incidence. This also we already discussed in reflection of light. All right. What is the point of incidence? The point when incident ray strikes another optical medium is called point of incidence. See, here it is striking at this point. You see, this is the glass slab at this point. So this is the point of incidence. I denoted with O. So O is the point of incidence. Okay. Number 3, normal. Okay, normal is very important, right? We already discussed in reflection of line as well. So the normal is a perpendicular drawn at the point of incidence. All right. So it is a perpendicular. That is a straight line which is perpendicular to this, right? You see, 90 degrees. So a perpendicular drawn at the point of incidence. See, it is crossing this point of incidence. It is known as a normal. It is denoted by N and N dash. All right, N and N dash. Okay. Then angle of incidence. This also is simple. The angle made by the incident ray with the normal at the point of incidence. See, the angle made by the incident ray with the normal at the point of incidence is known as the what? Angle of incidence, and is denoted by I, small I. Okay. And then refracted ray. What is a refracted ray? This is very simple. A ray that gets reflected. Okay. After what happened? A ray of light which deviates from its path on entering another optical medium. See here now, this was from in the medium that is air, but here it reflects back, okay, from here, but it enters another medium that is glass. All right, so this is a reflected ray, and it is denoted with O dash. You see, O dash. All right. Then angle of reflection. This is just the same as angle of incidence. Okay, so the angle that the reflected ray makes with the normal is called angle of reflection. See, the angle in which the reflected ray, you see, this is the reflected ray, makes with the normal. This is the normal, right? So this is the angle of reflection. Okay, this is the angle of reflection. Then the most important term, and a new term shown here, is emergent ray. Okay, this is a very new term. Now I will show you the result diagram. Okay, emergent ray. So listen carefully. What is an emergent ray? A ray of light which emerges out from another optical medium into the original optical medium. What do you mean? Emergent ray. You see this ray comes here? Okay, it stops here, right? However, there is another ray, because see, it strikes here, right? And this one, it came back out here. Understand? See, this is air, this is glass, and this ray is coming back out. So this is what? This is again air, which is a rarer medium. Alright, so see here. Forget about this upper part now. Alright, see now, this ray is coming here, right? After hitting this, what happened? It travels back outside. See this one. This is very, very important. This is a glass slab. This is a denser medium, and this is air. It is a rarer medium. So as per the rules, what happened? When a ray of light coming, okay, then you draw the normal again. Here my normal is denoted with M. You treat this as a, see this, when you cover this is the incident ray, this is the reflected ray, right? However, when you cover this upper part, this becomes the incident ray and this becomes the reflected ray. Now if a ray of light comes and incident here at this point, right, what happens? I already told you this, you draw a normal. Okay, after drawing a normal, what happened? You reflect, but it is from a denser to a rarer medium. So the reflected ray will bend away from the normal. As you can see here, it is towards the normal, right? But here it is away from the normal. Here this normal is M and M dash. Okay, so what is an emergent ray again? A ray of light which emerges from another optical medium into the original optical medium. You see, it emerged from it came from a denser medium, but it emerged back from its original, that is rarer medium, which is the air. All right, so that is the emergent ray. Next is angle of emergence. What is the angle of emergence? The angle that the emergent ray makes with the normal is called angle of emergence, right? This is the angle of emergence. This is the angle of emergence, sorry. The angle of emergence is the angle that the emergent ray makes with the normal. This one. Angle of emergence is this one. Okay. See, in which the ray makes with the normal. This is the normal, right? Here this is the normal, right? This one they make here, so this will be the angle of emergence. Okay, that one is the angle of incidence. All right, so this here I hope so you understood. We already discussed incident ray, and then point of incidence, normal, angle of incidence, angle this is reflected ray, angle of refraction, emergent ray, and angle of emergence. As you can see here, I wrote these points. All right, these points will help you understand, okay, with the diagram. All right, so you can look at this. Okay, you can look at these points which I wrote. That is, see, for example here, emergent ray, I wrote PO, right? See, this ray of light coming and meeting another optical medium, right? This is the incident ray, which is denoted by P and O. It will be easier, right, that way. So P and O, so you look at this and then you go through that again. Okay, so I hope so you've understood everything. Here in the next point is conclusions during refraction through a glass slab. Even in conclusions also they have discussed this one, which is the cost. Okay, the cost is just a small one, and the conclusion is this one, which I have just taught you. All right, so the conclusion is what? If the light goes from a rarer medium to a denser medium, then the speed of light decreases in denser medium and the ray of light bends towards the normal. And if the ray of light goes from denser to rarer, the ray of light will go away from the normal and the speed of light increases in a rarer medium. Alright, so I have finished with the conclusions as well. Okay, I discussed it beforehand because you will understand these terms later, no? Yeah. So I discussed it beforehand. So we already finished the conclusions as well, right? So you check this one. This one is very, very important. Okay, the terms associated is very, very important, and this diagram is also very important. So just draw the simple diagram which I just shown. Okay, don't draw as from the book. Okay, all those R, S, everything, don't draw all that. Just draw the simple one. Okay, because in this simple diagram you can see all these points, okay, which are important. All right, you can stop this and even draw this in your copy, this diagram. All right, so that is it for today's class. I will continue again tomorrow with lateral displacement. Okay, we will discuss the laws of refraction as well tomorrow. All right, so you read and understand whatever I have taught you today. All right, and as for the question and answers, please do it on your own. All right, for now, do it on your own. I hope so that the school reopens soon, then I can help you with the question and answers. But right now, I just want to rush with the explanation first. Okay, because this chapter is too vast. So I just want to explain the chapters first, and maybe at the end of the chapter, we'll discuss the question and answers. But that doesn't mean that you guys shouldn't do it. Okay, when I say discuss, I mean that you will discuss whether it's right or wrong. Okay, but this means that with each exercise, suppose today I am done with this, right, and tomorrow I'll be doing the other one, and then we'll reach to exercise 1C, right? Then I expect you to do exercise 1C, and I expect everyone finished exercise 1A and 1B as well. All right, because I cannot do everything on my own, no? So you have to help me also. That you have to do the exercises, and then we will discuss. Okay, you can personally text me if you have any difficulty, and I will try my best to give you the answers. Okay, so thank you.